Okay, so Kubernetes administrations we are gonna learn in this entire training program. Let's move forward. Okay, so we few questions we are going to discuss now. Why Kubernetes and what are the tasks of an orchestration tools actually has? Okay, and why this is trending. So uh see, the trend is why we are moving, why entire world is moving towards to infrastructure, moving towards to the Kubernetes, because trends from monolith to microservices. All right, so monolith data centers where you have a fixed servers or you have a fixed infrastructure. On top of it, you are creating a virtual machines or applications and all, and it is working behind. But those virtual services and virtual machines are fixed. Okay, and they are consuming certain processors, certain memories, storage and all. You need something which is in the form of microservices, which suddenly should come up when is needed, and when you don't need it should go away. So you need your infrastructure in such manner. That's Kubernetes now. Okay, now this Kubernetes basically increased usage of containerizations. Why it is being used? Because in today's generation, when we see the data center and cloud infrastructure, containerizations is used very highly in any of the data center environment or any of the infrastructure environment. So to orchestrate your containerization, Kubernetes is one of the tool. All right, now demand of proper way of managing those thousands of containers. Now question is, your Microsoft Windows Server 19, 22, these all are operating systems or Linux operating systems providing you containerization, right? You have a Docker. Independently you can install Docker and you can create containers and you can start using it. But the question is, when you have thousands of containers in your network, how do you manage them? Okay, how do you troubleshoot them? How do you operate them? So that's a big challenge. So you need some orchestration running behind, which will help you to manage, operate, monitor, troubleshoot this entire massive network. All right, massive infrastructure. That is the one. And the other reason is infrastructure cost saving. So if you have a fixed virtual machines, maybe on Azure or AWS or anything, it will have a fixed cost, right? So you have created a number of virtual machines, you have a cost. You have to pay a cost for that. Now for Kubernetes or container infrastructure also you have to pay a cost, but that is reducing down by creating or scaling up your microservices, scaling down your microservices, and very small set of services which runs your applications, and when you don't need it goes away, right? So you actually pay for pay as you go definitions actually becomes true here, right? So as many seconds, minutes, hours you use, you only pay for that much, and rest otherwise it will go away. Okay, now what features does orchestration tools offer? There are many different orchestration tools are available. Kubernetes is one of them. So what feature these tools are actually bringing up for you? Very first is a high availability and zero downtime. All right, so when you create any Kubernetes infrastructure and you create a pods and containers on top of it, any one pods fails, automatically it makes up another one running behind. Okay, so you have a zero downtime and high availability. Whenever your scalability on high performance, whenever you need high performance, automatically it can be scale and very faster at comparatively VMs. Okay, just like your virtual machine scale sets you have. So comparatively that it is very faster. Disaster recovery, backup and restore in your orchestration. Whenever any pod fails, automatically it can immediately recreates it. It can restore, it can, you can back up it very faster and with very quick clicks only. Okay, fast provision and serviceabilities. So see, when you want to provision any of the applications or any of the service, it's very fast provision, because already you have a container images created with you. You just can run your deployment, you just can run your script and can make your parts ready in just few seconds. Okay, so these all are the advantages of any of the orchestration tools we are using today. Now, when we talk about Kubernetes, there are hundreds of components. All right, hundreds of components are there inside Kubernetes, but we are not using all. We are using some handful components over there. And what are those all components? Few most important components we are going to discuss, and rest of the other components shortly, slowly will come up along with the chapters, and you will learn about them. Okay, so there are components like pods, like service, like ingress, like volume, secret, config map, stateful configurations, deployment, and all those things. So all of these components are something which are very commonly used, oftenly used while deploying, administering the Kubernetes clustering. And there are so many other services which we don't use very regularly, but are those also important? So those we will see during the requirements. All right, so let's move to discuss about each and every components. So very first thing is, what is a worker node? Okay, very first component is, what is your worker node? So the node is a worker machines in your Kubernetes, and maybe either a virtual machine or a physical machine, or dependent on the cluster, so which is carrying your actual workload. Okay, so this is basically your physical server. On top of it, we will deploy everything. Okay, so this is your physical server. So it could be a physical server, or it could be, let's say you are creating your Kubernetes environment on Azure, so you can create a virtual server on Azure. Okay, this will be your VM, or it could be your physical server, and then on top of it you will build your Kubernetes orchestration. So this physical server on top of it, which you are gonna build everything, is a worker node. Perfect. So this is your worker node. Now, on this worker node, we create very first component, which is a pod. So what is the first component we call as a pod? Okay, so remember very carefully about this. So pod, basically, if we understand, it is smallest unit of your Kubernetes. Okay, and pod is basically a orchestration over a container. Okay, so pod basically creating a running environment or a layer on top of the containers. Okay, so see, pod basically creates a running environment on top of container. All right, so basically your container is what? Container is a set of applications, and that pod basically allows to run that container. So container is the set of image, right? That image will have a operating system kernel, that image will have applications, that image will have all the required things. Okay, so that image basically is run by pod. Okay, so pod can run multiple containers. Remember that pod basically can run multiple containers as and they are managed as a single entity and share the pod's resources. So pod basically will have an IP address. Your memories and everything will be allocated to pod, and that pod will run your container image. Okay, your container image will be run by a pod. Now, a single pod can run multiple container. So ideally suggested to have a single container running on the pod. All right, just a moment, guys. Okay, so clear with that. So ideally, what I said is pod runs multiple containers. Okay, pod can run multiple containers, and that are managed as a single entity. And all of this pod will share its resources to the multiple container. Okay, now ideally, it is suggested to have a single container running on a pod. Okay, ideally in the real environment, always it is suggested as one pod, one container. Okay, so single container should be running on the pod. That is the idle case, that is idle scenario. Okay, now so each pod communicate with each other. Now look at this. So in my worker node, I can have number of pods. Okay, I can have number of pods. For example, I am running any application. So what I'll do is, one applications you will require, like let's say a website, a shopping cart website. All right, so that shopping cart website is the one part, and then it's a database is other part. So what I can do is I can create a two parts. One parts will have an applications, another parts I have created for DB database. Okay, so I can create two different pods, and I can keep these things on two different things. Now the question is, when I have a two pods or multiple pods created, how does they communicate to each other? Okay, so each pods communicates with each other with the IP address. And remember that IP is assigned to a pod and not to a container. Remember that always. These two pods are communicating to each other with the help of IP addresses. Okay, like this. And IPs are assigned to a pod, not to the container. Okay, so now question is, what happened? What I said is IP is assigned to a pod. What happened if any pod dies or crash? What happened if this pod is failed, dead? What happened? So if any pod dies or fails, then new pods will be created, and it will be getting a new IP address immediately. So this pod is fail, your Kubernetes will create the another pod immediately. Okay, it will create another pod, and that pod will have a different IP address. That pod will get a different IP address, just like it is taking up from a DHCP or taking up from the IP address pool. What will happen? What's the challenge? So the problem is, if every time your pod gets new IP address, then your applications or database configurations may be required to change all the time. Okay, just think over. This is an application, and these applications you have configured with your database with the IP address, and you have defined IP address in hardcode configuration somewhere. This pod crashed, new pod is created, it has got new IP address. Will it work? No, because you need to go to the application, change that IP address, do those configurations back again, then it will work. Okay, so that is a problem. That is a problem in a pod while communicating to the IP address. So, and this will happen because pods are so many pods suddenly getting created, so many pods suddenly getting deleted, right? So this is dynamic services, microservices. So to avoid this, there is a new component called service. Okay, we can avoid this problem. by next component we called as service. Okay, so why service components comes up to the picture? Try to understand. We discussed the problem in pod. While those pods are getting deleted and new pods are created, new IP address comes up, and that actually mess up entire configuration, right? So why this service component actually comes up into the picture? So it is because we need something which should not change or die even your pods dies. Okay, so we need something which should be remain fixed always. So service will remain fixed. Service will be a separate component. Even though this pod is dying, service will remain there as it is. Okay, so and we will assign an IP address to the service. Okay, service IP address also would be a part of a service. So we will have a service here, and service will have a permanent IP address allocated. So you have a permanent IP address inside this service. So even though this pod is died, new pod is created, the same service will get attached to it. That means your IP address and other things what you define in the service will remain the same. So your problem is resolved. Even though this pod is dying and creating 100 times in an hour, no problem. All right. Perfect. So life cycle of the pod and service is not connected to each other. It means if your pod dies, still your service will be there. Okay, unchanged. And when new pods comes up, then the same service will get attached to it. So your service and pod's life cycle is isolated. They are two separate things. So when a pod dies, your service will not die. Okay, when you change or modify in your something in your service, your pods will be separated. Okay, so both are to each other. But when your pods dies, your service automatically will get attached with that particular pods when new pods comes up, right? So this is the advantage. So life cycle of the pod service is not connected. They are separate entities. Services are permanent. Okay, whatever services we are creating there, they are permanent. They will remain fixed. Now there are two types of services: internal services and external services. Okay, now very quickly you need to understand what do you mean by internal service. So internal service, which is used to create internal communications within the cluster. All right, so internal services, that means which are basically used to create communications within your cluster. Okay, for example, let's say this is an example of internal service. Your this pod and this application is communicating backendly to the database. It is communicating through the internal services. All right, now what is external service? External service, that means which is used to create communications from internal or let's say internet or any of the external resources. For example, you want to access something, you want to access your applications from the internet. All right, for example, let's say from outside you're accessing, let's say http:// and you are putting the IP address of this pod, let's say 120.10.100.123 whatever :port. Okay, so you want to access this from your browser. So where it should come, where does it gonna come? Okay, so if you want to access your applications, and then you can use your node's IP address. Okay, so you will use your worker node's IP address, and you will use a port. So that port is binded with your service, and service will tell to which pod it should go. So 8080 is assigned to this service, and this service is redirecting attached to this pod. So your request will go here. You use, let's say, 8012. So this particular port number configured in this service, and this service is attached to this DB. So it will go to DB. If I change your port number, it will go to DB. So your traffic is coming to the worker node's IP address, and based on the port, your service will identify which pod it should go. All right. So now ideally what happen when you access such URL, when you want to access such URL, but this particular URL, when you access from the outside, rather this is not allowed in any of the business domain. Why? Why such URLs or such IP addresses are directly not allowed from the business domain? Due to security vulnerability. If I directly allow this IP address to access from outside, any attacks can happen, or anyone can send, okay, DDoS, denial of, you know, uh, services attack there. Okay, denial of services attack somebody can send, and if you are exposing your IP address outside world. All right, so that's a problem. To avoid this problem, what we do is we create a service that is called ingress. We create a one more component that is called ingress. Okay, so ideally if you want to publish your website outside, then you should do like for example, instead of this, we should do like, let's say, HTTPS, and we can create a FQDN. For example, let's say myapps1.com. We should create like this. So we created this FQDN. All right. So to achieve these goals, we need to have one more component, important component, which is coming up into the picture, that is ingress. So instead of direct public IP address, I want to access through this way. So to make this way, we need ingress. So this is an ingress component. Let us understand. Okay, so what this ingress basically does, ingress basically is created to allow external communication, basically, which is coming from internet. Okay, to your internal services. So ingress basically works like a DNS service. Okay, so you can create various different URLs along with subdomains and all. So anything comes up here, then it redirect your request to the particular service behind. For example, let's say I want to access HTTPS : I want to access, let's say, app.nits.com. So this is the DNS entry I have created, and this app is I have binded this with service, this one. So when I put this, ingress query will come, and ingress will identify, okay, apps pointing to which service. So it is pointing to this service. This service means this part, so it will go here. Now if I access here HTTPS : let's say db.nits.com. So ingress has got a rule. DB is equal to which service, it is binded to this service, so it will send to this service and it will reach here. So this is how it is acting, just like a DNS. Just like in your traditional network, your DNS resolves name for you and redirect your traffic to that particular IP address. Okay, similar way ingress. So ingress actually working here exactly same, just like a DNS, and it is avoiding to expose your IP address, your worker node's IP address outside directly. This is very, very important. Okay, so that's ingress we understood. Okay, now next come up to the config map and secret. It is very important. Okay, so what is a config map? So just think over. Now the question is how that configurations you do between application and pod. Okay, I have an application here. This is an application, and I have a pods. Okay, so application and pod between, how do I do configuration? How do I configure my applications on top of the pod? Okay, so usually it's built in. Okay, whatever application and pod is by default built in with the container image. When you create a container image, that image actually has got built-in applications and pods configurations, everything. Okay, but the issue is, what if you do any changes or any versioning or in application? When you take up any image, that image has a pod definitions, and that image has a application configuration. That is fine. आपने image deploy किया, उसके साथ ये सब आ गया. But what if you want to change the application, if you want to upgrade the application, if you want to rebuild, if you want to do something, तो उसके लिए क्या करना पड़ेगा? आपको वापस जाना पड़ेगा, वो पूरी कंटेनर की इमेज पूरी रीबिल्ड करनी पड़ेगी. ओके, इमेज पूरी रीबिल्ड करने के बाद वो इमेज को वापस से बिल्ड करना पड़ेगा. बिल्ड योर एनवायरनमेंट इमेज. ओके, then you need to upload this image to your repository location. Okay, जहां से आप उसको pull out करोगे, और फिर वहां से आपको उस इमेज को वापस से पुल करना है, पुल योर pod image. So that is a long process, and that will require a downtime also. This is quite lengthy process as well. It will require a downtime. To avoid this, okay, that's why config map is basically used to do external configurations to your application without recreating image or push pull into the repository. बिना container image को फिर से बनाए, recreate किए, you can do configurations. You can do all of these things. You can avoiding recreating images and pushing and pulling this, and you can do. How we can do it? That we can do with the help of config map. Okay, so config map is something which will keep comparing whatever we are defining into the config map. What it will do is, it will just take up and compare. Okay, what is there, what is here, what is in config map. It will compare, and whatever new is there, that it will push it here. That's it. Whatever new changes, new settings is there, that it will push up here. That's it. All right, so this makes your job very easy. So config set actually takes your compare the configurations of existing configurations and your provisioned configuration, and it will compare and deploy only the changes. Okay, now what is a secret? Secret is a key, okay, which will actually authenticate while pushing any configuration. So if you have any passwords or digital certificates and all, so secret key will have it will keep that secret keys encrypted, so that if anybody has a config map, they should not be able to read that secret key from that file. So that is secrets. So understood? So any of the configurations on the pod related to your application and all, we do through the config map to avoid a big recreation images and all those things. Perfect. Now volume. Okay, we talked about pod, containers, config sets, and all ingress services and all about thing. What about data? So this is my business application, and a lot of transactions, a lot of things are happening here, and that data, that database should be stored into somewhere at the fixed place. Okay, so volume is very important. If you are storing your data on the pod disk, default disk only, what will happen? Accidentally, if this pod fails, your entire pod is gone, and that pod will be get recreated again. That means your data is also gone along with this pod. Okay, so for that purpose, volume component has been created. So volume is very important component to store your data. Okay, so as I said, now you can assume that if you have a pod running database, and what if that pod dies suddenly with any error or any of the problem happen and that pod dies? So in such case your data will be lost. Okay, because it was within the pod only, but you want your data should be available persistently. and reliable. Even though your pod fails, your data should remain. Okay. To avoid this situation, we are using a component which is volume. Okay. So volumes basically allows to attach your physical hard drive. So this worker node has got a physical hard drive, और इस hard drive में मेरे पास D drive है, E drive है. I can attach that particular drive to the pod. Okay. I can attach that drive to the pod. Okay. And then whatever we are doing, that data is storing in this physical drive. When this pod dies, still that drive is there. Still that data is there. And I can I can create another pod, and that drive will get automatically attached with this with the help of config set. Okay. So like that. So storage could be in a form of local worker node, or it can be a form of remote servers or on the cloud. So pod को जो भी आप storage assign करते हैं, that can be into your local worker node, or that can be from any remote. For example, you have a Azure storage account, so it can be from there also. You can attach that also to your pod. Okay. Or you have any SAN server or any NAS and all, so you can attach that as well. So it could be a remote storage, or it could be any of the cloud, or yeah, so that is a remote, or it could be a local storage as well. All right. So advantage, store a local machines, and remote or outside to the Kubernetes also you can have this, and they are very, very persistent. Even your things dies, your pods dies, it will remain there. So that's a volume. Now next component is a deployment. What is that deployment? So deployment, that means it holds the full setup. Okay. Complete configurations and installation, image deployment, everything is holded in a file that we call as a deployment. Okay, so let's say if you want to create a pod, what you need to do, you need to create individual many things. Like you need to pull out the image, container image from the repositories. Then you need to create services and so many things and other configuration. Instead of that, what we do is we create a deployment file. And in that one deployment file, we define everything, and we just run that one file and everything will be done. So deployment is an abstraction layer on top of your pod. So Kubernetes engine actually keeps checking the setups of your deployment, and anytime if any pod fails or dies, it execute that deployment. अब deployment का फायदा क्या है? आपने manually ये pod create किया और वो delete हो गया तो हो गया, खत्म. फिर आपको जाकर create करना पड़ेगा. But आप चाहते हो कि that should always remain. So ये pod fail हो गया तो क्या होगा? आपको manually create करना पड़ेगा. But what do you want? If you have a deployment, यदि आपके पास deployment है, तो इस फाइल में, deployment के फाइल में आपने define करके रखा है. Deployment actually content the image, pod का image क्या रहेगा? Okay, what is the image? What is the type? What type? What are the services? Okay, what are the replica? Replica मतलब एक pod की कितनी replica चाहिए? मुझे चाहिए 4 pod. Okay, replica कैसे scale up, scale down होगा? This all things is in deployment. अब आपने ये deployment बनाया और उसमें एक replica रखा है. Kubernetes engine क्या करता है? हमेशा इस replica को और current config को कंपेयर करते रहता है. अब जैसे ही आपका एक pod डाउन हो गया तो ये Kubernetes engine देखता है क्योंकि there should be one replica, one pod, but right now this pod is failed, so there is a 0. तो ये क्या करेगा? इस deployment से तुरंत एक pod create कर देगा. So deployment and current configuration always being compared. इसमें यहां पर उसने बताया replica मैंने रखा है कि 2 replica होना चाहिए, मतलब 2 pods हमेशा चलने चाहिए. तो जैसे कोई एक pod फेल हो जाता है तो Kubernetes engine देखता है कि there should be 2. Deployment says 2, but here right now there is 1, so immediately it will create another one, right? So आपने यदि कोई pod delete भी कर दिया तो Kubernetes engine वापस से तुरंत उसको create कर देगा, क्योंकि वो deployment को check करेगा कि deployment में क्या बताया है कि हमेशा क्या होना चाहिए. So it always will compare कि always there should be 2, so it will maintain 2. So it will keep comparing. So you put a one deployment image and your Kubernetes engine always keep checking that image and will keep maintaining what you suggested, what you told in deployment. Understood? Okay. So this is the deployment. Now let us understand the Kubernetes architecture. Okay. So Kubernetes architecture, basically each node can have a multiple port, as right back I said. Okay. So to run a Kubernetes architecture on any of the worker node, there are three processes must running on each worker node. On this worker node, there are three most important processes must run. Very first process is container runtime. Okay, container runtime is the first process. What is the use of this? So container runtime is just like a Docker, okay, or any other technology. Docker is one. You can use any other technologies as well. So container runtime basically facilitate you. Container runtime communicates with containers and nodes with the interface, and that interface basically called as a kubelet. Kubelet. Okay. So kubelet basically starts your pods with the container inside. Kubelets ka kaam kya hai? Kubelets actually allow you to communicate. No, it is a communication interface between the containers. And kubelets basically starts your pods with container inside. Okay, pod है, pod के अंदर आपका कंटेनर रन हो रहा है, तो ये pod को स्टार्ट करना और उसके अंदर कंटेनर को रन करने का काम कौन कर रहा है? Container runtime. This is first component. Okay. Second is communications via services. Second important component क्या है आपके Kubernetes in architecture का? Services. Services we rightly discussed back. Okay. Services basically bridge a gap, bridge a communication between multiple pods. Okay. And services will remain persistent, right? Services are isolated from your pods. When your pod dies, still your services will be there. Okay, so second important component in your Kubernetes architecture is service. And third important component here is kube proxy. Okay, so kube proxy is also one of the most important. So kube proxy component basically responsible to handle your all ingress. Okay, this is responsible to handle your all ingress, anything coming from internal communications, internal ingress or external. This is handled by kube proxy. So these all are three. If you don't have this, then internal or external communications will not happen. That will be individually pods will be running over there. All right, so that's the architecture. So these all are three most important component when we talk about your Kubernetes architecture you want to build.
Sir, ये kubelet फिर से बताइए.
Kubelet is a container runtime. Okay, so it is just like a Docker, and this container runtime actually communicates with the containers. Okay, and basically nodes with the interfaces. And kubelet basically used to start your pods with your container inside running there. Okay. All right, now production deployment. When we talk about realistic production deployment, how that realistically we deploy. So realistically, when we talk about Kubernetes orchestration, it require components. Like it will be splitted in different parts, two parts basically. So you have a master. So master could be one or could be many, or ideally it is suggested to have a two master, so that master will have certain components like your API server, your scheduler, your config manager, your HCD database. Okay, this will be having inside your master. and these all are replicated. For example, if any one master fail, it should be other should be able to take up. So here your all things will work. Okay, and this is actually worker node. So actual load, actual your operations, actual your workload is happening here. Actual your pods are working here. Okay, actually your pods are working here. So your master nodes could be with the minimal configuration. They do not require much configuration because complete orchestration, administration and control happening here. And here actually your load, actually your worker load, your thousands of applications and servers and everything is running here. So here actually you need a configuration, good configurations, hardware configurations, as much workload you're loading on this. So these all are your worker nodes. So this is a enterprise network. So in any organization, we built a Kubernetes infrastructure like this. Now, if we want to build a test lab in any organizations, we are doing a lot of testing things also, right? And you are learning this Kubernetes, so you will have to create your own lab. So you can create in this way. Okay, so you can have your one single node here, single node, and on that single node you can have a master processes, all of these master processes, worker process. That means both master and worker, or master and slave, both will run on a single machine, and your nodes will run. And on top of it, your runtime is Minikube. So mini Kubernetes is your runtime, and on top of it, everything is running over there. Okay, so this is a two orchestration example that is actually used in a prod, and that is basically used in test. So in any organizations, you have a two environment. One is a prod environment, another one is a test or dev environment, development environment or a test environment. So we use this setup for a test and dev environment, and we have a prod environment where actual production is going on. Perfect. So it is like that. So now we understood all of this component. We are gonna build a small test lab and gonna see how to deploy these things. Okay. So we are gonna deploy this with this environment, which is Minikube. So what very first thing you required is you must require a virtual box, and you must require a Linux over there. I'm just starting this. Okay, failed to open sessions. Okay, so it is talking about some network binding issues. I'll bind with this. All right, so you can create one Ubuntu or any of the Linux flavor virtual machine on your virtual box.
Yeah, we can do from AWS also.
Yeah, any platform.
You are doing in?
I'm doing on my local system.
Okay.
So you can have this on anywhere. Okay, you can have this set up on AWS or Azure, GCP, any environment you want to choose.
Okay, thank you.
All right. So if you are doing this on AWS and all, you need to take a configurations, heavy configurations, like at least you take 8 GB or 16 GB memory. Because your worker nodes, pods, and everything will get created on top of that. Okay, so let me see if I get an IP address. Okay, I got the IP address from my router. That's cool. Now what I have to do is let me check it out how much memory I have allocated to this device. Okay, I have only 4 GB. I have to increase a little more. Okay, so probably I'll go at 192, 8 GB. That will be cool. Okay. All right, now what I need to do is if config, I have an IP address which is 192.168.10.107. So I cannot use mouse pointer inside that. So what I'll do is I will First install SSH server here. I'll do now. I'll create a notepad for step by step. Okay, so very first what you need to do is you need to update the Ubuntu. Or before updating and all, I'll just install SSH. Install open SSH server. Password. Okay, newly installed. Now 10.107, and now I can go to PuTTY and I can connect. 192.168.10.107. Yeah, that's good. Great. So I'm here now. I can use my mouse pointer and everything to explain you more better. Okay, minimize this. I don't need this. Okay, this is not needed. I'm here. So what I did is very first command I did sudo apt install open SSH server. I did that. Okay. Just to show you, if you are doing again, there is no problem. It is saying already installed. Okay. I'm taking up this command for you. Install SSH if you want to have telnet access outside. Okay, now next important thing what you need to do is you need to update this so that it must have latest packages and everything. You should update this. How to do that? Sudo okay apt get update. All right, let it update. Let me take this command for you. All right. Now, meanwhile, I'll go and I'll check here in the setting. Okay. Most important thing is you need to go here and processor. Okay. So I need to go and enable this. Enable nested VT technology. Okay. So virtual technology must be enabled on that processor because on top of it, you're going to create virtual environment. Okay. So once it is getting updated, we have to do that. Okay. Okay, let it complete. Taking time. Depending upon your Ubuntu version as well. Okay, so for example, you have deployed your Ubuntu 19 or something 20, then current version is, let's say, 22. So that much gap, that much new patches, new services gap should be there. So it is all depending upon that. So if you have latest version of Ubuntu image deployed, then you will have limited updates to be taken from update repository. Okay, it is almost about to finish. Okay, so I think that is disconnected. I need to restart it, or I'll just shut down it to increase processor or to enable VT technology. Net 0. Okay, that's fine. And another one is a processor. Okay, I'll just enable this two technologies. That's it. Okay, so it went to shell. Guys, can you hear me?
Yes, sir. Yes. Yes.
Okay, great. My mouse is stuck actually. Okay. EFI, I don't need this. So if your laptop is not supporting EFI firmware, then uncheck that. But if anybody has i5, i5 and current generation 2 or 3 latest generation version that have a instead of BIOS it has EFI firmware, so then you will not have that problem what we have seen now. But if you have still BIOS in your laptop physical system, then uncheck that. Okay, so what happened here is, see, config, if config, I got a different IP address because I got connected to some different network due to power cut issue here. So I need to do that once again. So remaining one only it will take it up. Okay, so it's done. Now, what you need to do is you need to install your HTTPS transport. Okay, so how to do that? Sudo apt install and okay, apt transport HTTPS, that you need to do it. Okay, let me take this image. Oh, sorry, not image, the command. Now I need to access through putty, then only I can copy and paste. Let it complete. Okay. If config 192.168.235.111. Oops.
I 192 हो गया.
Type mistake. 192.168.235.111. Cool. So what command we have done? I'll type this command once again to show you guys. Sudo apt install apt, what was that? Transport HTTPS. So this command, you need to take it. So this command is basically to enable transport, HTTPS transport. Okay, this is the command. Now this part is done. Next, what you need to do is you need to upgrade whatever update and all things you have downloaded. Okay, sudo apt-get upgrade. Okay, yes. Do you want to continue with that? Yes, I'm upgrading all the services available there. So this updating is very important because whatever services you are going to run, those services will ask for dependencies. So this update and upgrade has got the dependencies
ये अपडेट अपग्रेड ये पुट्टी के कमांड पेज में होगा और या उबुंटू के कमांड पेज में होगा.
Putty and Ubuntu is the same thing, Fabian. Both are the same thing. I just took this putty to have the access of my cursor, like I can copy and paste something,
अच्छा
which
अच्छा.
I cannot do here. It is not allowing to take mouse inside. Rest everything is same.
हाँ वो दो अलग पेज ओपन हो रहा था ना तो इसलिए मुझे लगा ऐसे.
Okay, okay.
ओके.
Okay. So this upgrade updates on all those things that you need to do only once while building your Ubuntu. Okay, so it's done almost. Now it is setting up all the libraries. Okay, so after that, next step, what we have to do is we have to install KVM. Okay, or KVM, or we can install VirtualBox. We are using VirtualBox, right? So VirtualBox hypervisor. Okay, so we have to do that. If you are using Red Hat Linux and all, you can install KVM.
सर
Mhm.
AWS चालू हो जाएगा सर नेक्स्ट वीक से अगर है
Yes, probably. Okay, why it is taking time? Okay, it's done. Okay, now as I said, we have to install KVM. So all the dependencies should not give any problem because you have updated it. So let's say sudo apt install, we are using VirtualBox, right? So VirtualBox, and that is external package. So VirtualBox external pack. Okay, yes, I'm taking up that. Okay, now after this, most important is now we have to download the runtime environment, which we are creating on on the base machine, right? On the single node, everything. So we need Minikube. So that we have to do. So what we have to do, download and install Minikube. We are doing this. So that you can download from the URL. I have this URL available here. So we will use this URL to download Minikube. I'll share you this as a part of document. So that command you need to run here. Let's see, it is done. KVM hypervisor, it is installing. Okay, so this is very important. Without that, you will not be able to run virtualization on top of virtual machine. Do you accept the terms of VirtualBox license? Yes. This is depending upon your internet speed also, guys. Oh. Why it is stuck? Okay, so that is installed. Okay, done. This is done. Now I have to stop it. Oh, sorry, restart it. So instead of that, I will. Okay, it will not happen from here. Why I wanted to restart, but I shut down it. Why? Because you know, my primary internet has come up. I'll switch to my primary internet so that it will be a little more faster. Okay, now I'm back to the system. All right, so system is back now. I'm here. Let it begin this. Okay, now let's see if config, I got the IP address, I can connect to putty. One 192.168.10.103. It's not connecting. Okay. And it's 6. Okay, so we have not received IP address yet to that interface. Adapter is resetting. I have to give some time to reset this adapter. Okay, I got it now. 192.168.10.103. Some problem. Okay. Okay, no problem. So I'm not getting putty. So what I can do is I can just install mini Kubernetes here. And how we do that? We need to use wget command. So wget command basically used to download anything from internet. And this is Google APIs. Okay, from Google APIs, we need Minikube releases. There are many releases, so we have to get for latest Minikube, and that image name is Minikube Linux and AMD64 version we are using. Okay, so we will give that enter and it is coming up. So we are installing Minikube. All right, so let's get this Minikube installed over there. This is the main orchestration, right, on your worker node. So already I have shared you this command. I'll share you this document. This is the command, okay? Storage API, Minikube, release latest Kubernetes. Now after that, we have to install kubectl for command access. This will give us a command line access. But that is second activities. Your Kubernetes will be working fine after this. Okay, so this is 69 MB program actually. So it takes around 1 or 2 minutes to download and install. Okay, this is done. Okay, it is saying Minikube Linux MD64 is saved. Now what you need to do is you need to give this file executable permission. Okay, it is there. So how you can give? Okay, plus adding this one and Minikube. So I gave executable permission. Now this one I need to move into Minikube folder. So I'll go, which will set the environment to run a command. So move Minikube where I want to move. I want to move user local bin and Minikube. Okay, because here your environment is installed. So Minikube commands you can run from that environment. Now if I go Minikube and I want to check version, look at this. So you got Minikube version and it is showing version. That means it is absolutely working fine. Perfect. So till now we will take a break till now. Further to we'll take it up tomorrow. All right, guys. So make your system ready till now and further to will catch up tomorrow. Tomorrow same time.
And sir, वो Azure का